Not so bad. I'm enjoying this first visit to Instagram.
Yeah, you are an Instagram virgin today, aren't you? But you're picking it up. We had a little chat before we went live, and within 5 minutes, you're navigating this pretty well, I'd say. Better than me, better than me. So I can see we've got people starting to join us now. Hopefully they'll realise that, we went off and now we're back online again. It's a real pleasure to have you in the series and to catch up. Now, you've recently joined a new institution, haven't you? Tell us a little bit about it and what you're doing there.
I was at Newcastle University as a professor of experimental architecture, and in November I became a professor of regenerative architecture at KU Leuven, the Catholic University of Leuven. It's a huge university. It's very old. It's spread over three cities, so Leuven, Brussels and Ghent. And it's a great place to be working. The architecture school's in a beautiful old monastery. It's just a real delight to be in the old buildings, and the buildings in Ghent are just fantastic. So a lot of mixture of modern and very old buildings, but the architecture works together really well. You can see it's a real architect's city. It's just fantastic to be around.
Oh, brilliant. I'm glad you're enjoying it. I know I knew it was a big university, but I didn't realise it spanned three cities. That's quite extraordinary.
Yeah, the main campus I think is Leuven, so that's the scientific campus really. More recently the arts have been assimilated within the big beast, including architecture about 10 years ago, and now Luca, which is the arts community, is also starting to join the university. So that process is, in progress. But it's great, to actually have a solid science university now that's attracting the creative arts and design. It makes it a really interesting place.
Yeah, a real hub of STEAM, of the sort of interface of the sciences and the arts and architecture.
Yeah, so there's a lot of focus on interdisciplinary practices, and also about, how does one go about those, and what kinds of value in innovation does art and design bring. I think these are very important and big questions that are being asked, and I think that the scientists here realize that in order to innovate, in order to share ideas, that different ways of communicating are important, and design and arts bring something new to the conversation. So it's really good to feel that there's an environment that recognizes that.
Brilliant, brilliant. Well, I know that a number of people within the growing community know of your work because your name has come up a lot in the best possible way, Rachel. Your work's been cited quite a lot as well. So I know that together with those joining us today, there'll be a number of people that will probably catch up with this video. But I thought for the benefit of those that don't really know much about your work, and really, how you got involved in this, the general area of living architecture and the sort of the bio disciplines and all that interfaces human and non-human systems more generally, I thought maybe it'd be interesting for them to just hear a bit about how you got started, what drew you to this area, and really a brief bio about, how you came to be where you are.
Brief.
No, it is pushing it, isn't it? It's ambitious.
Right. So I'm going to start with I'll start at the beginning. I'm actually a medic, so I've trained and practiced as a doctor. And when I was a medical student, I went on a sabbatical to Pune in India, where I worked with people with leprosy. And I saw how very low-tech technologies could really transform people's lives. But it wasn't enough, because the stigma with having leprosy and the fractures in the in the families that was produced by the social consequences of having this particular disease, really made me think and confronted me with actually quite a holistic view of what being in the world was about, and how just focusing on the body was really not enough as a discipline alone to understand how we start to make people's lives livable. And I think I also at that stage realized that you didn't have to have a perfect body, because that was effectively the medical doctrine. You know, you had to restore the imperfections in someone's anatomy back towards a standard. And I realized that if people, you know, had lost their limbs and their eyesight, and yet they were able, with the support in this community, to have a family life and be loved and actually feel accepted, that you know, the disciplines and the, let's say, the kind of looking down for solutions that science tends to do was not synthetic enough to be able to make these connections across different kinds of knowledge, to find another way of living together. And I realized it wasn't just the body I was interested in. So when I went back to the UK, I was totally at a loss to know what to do next, because I knew that the kinds of questions I had weren't in medicine. And so I started working with artists, and they'd come to me to try and find out how they could change the body. So I used the medical system in order to ask questions that they had, and started working with artists. So people like Stella, Orlan, Helen Chadwick, even Franco B. This idea that the body was a site for design was an important question that came up. And from that, then I started to have my own questions from the scientific background that I had. And the thing that came out was this idea of metabolism, not as a kind of metal technical object or something that invades, but a kind of power within us that is transformational. And my questions were really about, can we use this ephemeral thing, or this flowing thing called metabolism, to actually bring about technical changes, material changes, bodily changes? Could this be some kind of integrating strategy, not in a metaphorical way, but in a very literal way? And so I started to try to find, my first job was to try and find a model, because as a, you know, with scientific background, I actually want to make stuff. I want to do an experiment. I don't just want to theorize. I kind of want to prove whether it's true or not. And so I was looking for a model that would help me understand better in a very practical way what a metabolism was. And this was where I came across the Protocell, which was at the time a kind of stripped down minimal life, but it wasn't a life yet. It was just a bunch of chemistry. And this was perfect for me, because all the narratives about how you design something were really DNA centered. That DNA was really the driver of all forms of biological existence. And there really hadn't been a narrative about how the influences outside DNA actually start to shape us. So I was looking for a metabolic model that wasn't always already preformed and prejudged by the presence of DNA. And so the protocell, which, I mean, it's a contested term, right? Protocell in the Steen Rasmussen and al. School of thought is the first artificial cell. That's not the version of protocell that I subscribe to. With Martin Hanzuk and Takashi Ikegami, the protocell was the first cell-like entity that precedes a cell. So there's a kind of ontological difference between the two. And so it belongs to the dustbin metabolism first, origins of life theories. So coming from this metabolism first, the first thing is not the gene, it's metabolism. And this protocell, we now, I think, would probably call it the dynamic droplet because of these ontological frictions. So the dynamic droplet then became this kind of technology, drawing object, body, a spatial system that enabled me to see and imagine and be with another way of being a body, another way of being in space. And I could start to hack it and take it for a walk in different places to try and see how it reacted in all kinds of different situations. And so I did most of the practical work at the Southern University of Denmark in Stine Rasmussen's laboratory with Martin Hanzik as my chemistry supervisor. That was an incredible time. And also Hans Toffland, who's just an amazing, well, he's an inorganic chemist, but he was also an alchemist. So I had this incredible environment, and also went back to the Bartlett then to think about how this this entity could become a spatialized system. How might we represent it, draw it, interrogate it? And so, yeah, that formed the basis of my PhD. And then as I wanted to go forward, I realized that in order to interrogate this in a more sustained way, I needed a different model, that the Protocell had taught me a lot about the spatial topologies and idiosyncrasies of metabolism, its ability to transform and surprise. That was amazing. You know, this is a technology that totally takes you by surprise, and that's why it's so fascinating. You can lose yourself in this world because it's like a theatre, that all these events start to declare themselves, and it's a whole bunch of bodies kind of reinventing space that's so alien that it's an incredible spectacle. But I wanted to go further again and figure out some of the protocols, some of the kind of ideas I'd had. I wanted to take them further, see if they could become more persistent, not necessarily permanent, but persistent. And that's where the idea of working with microbes came in. There's been already quite a lot of work done with microbes and eukaryotic cells. So Symbiotica had done quite a lot with their cell culture, you know, the victimless meat kinds of explorations. And eukaryotic cell cultures were not as robust as microbes, which being the technology of the biosphere, let's say, are way more creative and way more robust than eukaryotic cells. So I decided to write a proposal, because by this time now I need laboratory equipment and I need more expertise than I've got. And so I wrote a proposal to the EU for the idea that living microbes could transform our relationship with energy and work if we could spatialize them in a certain way. And of course, the bioreactor, whether anaerobic in the microbial fuel cell or photosynthetic, as with the algae photobioreactor, different kinds of bioreactors potentially could have a conversation with each other, and almost like building a metabolic body. Maybe we could grow up these different microbes in little spatial environments, or cities for microbes if you prefer. And then we could ask them to exchange goods between those cities as a kind of trading system. And so this project got funded as the Living Architecture Project. And I thought, for me, you know, I'm interested in the idea of the city, but I think under-theorized is the idea of the microbial city within the home. And the home is the place of human empowerment. So a city is fine. We love being in cities. Cities are great. There is a kind of urban dimension. But theorizing the home for the 21st century was really interesting for me, because there's a relationship between the body, metabolism, metamorphosis, animal economy and ecology that's situated around these ideas of ecos, or the Greek notion of an economy of exchange that supports the basic units of living that arises in a critique of the home. So the city of microbes is situated within a home, establishing an economy with humans, thinking about our resource use and our body as a partner within that system. So as you know, people in this discussion will know, that our body is already, you know, in the third millennium, new imaging techniques came out that allowed us to see microbes as populations and ecologies in a way that wasn't possible before, because of the advances in sequencing techniques and a lot of kind of molecular biology advances that just made it possible now to see populations of microbes. And with that, we started to see them inside our bodies, and we didn't realize just how many of them were. And I remember the figures that were being thrown around at the time, which was like, we are outnumbered by microbes 9-1. I think it's actually now around 50-50 with further analysis and consideration of just how microbial we are. And so the idea that, at least each one of our cells is accompanied by a much smaller microbial cell that's mostly sitting in our guts, but they're everywhere. The idea that this stuff could get then entangled inside these little cities that were designed, that we're starting to talk to each other through a very oversimplified economy of exchange. So we looked only for single forms of currency that we could actually track, because if we did everything, that would be a pretty hard job. But the idea then would be to follow through our relationship with our body fluids, because these cities are transforming our own excrements. So in the Living Architecture project, we looked for urine and wastewater, so grey water from our kitchens and bathrooms. But it'd be quite possible to have all the solid excrements, provided they're in liquid form, feeding these microbial environments. And in that way, they're a little sewage system. We don't have to outsource the decontamination and the repurposing of our wastes, either to sewage systems or to the soils. We actually have a spatial system that works with an ecology of microbes, that deals with a metabolic economy, so they're trading different products. And that actually is something that can, I don't like the term circular because it sounds closed, and I just resist the idea of living systems as being closed systems. I think that they can be quite efficient about how they process molecules, but effectively they need an energy source, they need a sun, they need some basic income from the living world. And so that's why I resist this idea of circularity, although I think it is a good way of thinking about the journey of the carbon in our bodies and the nitrogen and all these really incredible chemistries that we're made up of and that we let go of, So yes, this idea then that maybe our homes and our bodies are actually interlinked. And maybe the kinds of systems that we're using in our homes that have been suggested by modernity are the kinds of things that make a good modern life, like industrial scale machines or, fridges that consume energy that needs to come from a 230 volts supply. We've tipped energy use and production out of kilter with the way that the living world works. So maybe by using microbial bodies, we can actually, instead of waiting for the microbes to die and then get transformed into concentrated little packages called fossil fuel through geological scale forces, maybe we can actually work with the microbes in a living, dynamic way and set up new relationships by different interfaces with them, and actually understanding the value of those exchanges as they freshen the air with oxygen, as they clean the water from organic matter, as they detoxify toxins and chemicals in our waste streams that have come into our bodies from elsewhere, and as they even produce goods that maybe we could actually program. And in these series of bioreactors, we actually looked to using synthetic biology. Now, I have a particular view of synthetic biology. I think synthetic biology, as amazing as it is and as fantastic as the science is to be able to, lift up the car boot of a microbe and start tinkering around on the inside to, make it do stuff that it didn't do before or produce more of stuff that we like. I think this is actually a first step towards a new conversation with microbes. I think that maybe within 30 years' time, that synthetic biology components for looking at the creativity associated with microbes will be greatly reduced. And the reason is the synthetic biology interventions are unstable. Microbes tolerate them for a while and then go, no, I've had enough of that. I don't want to keep working like that. I want to rest. And so the genes get thrown out. But the other part of that is I think that we will develop microbial libraries, and that with all the things that we're trying to see, what would happen if using the tools of synthetic biology will in 30 years' time be possible with wild type microbes, and we'll know how to search for them and retrieve them and go, oh, we need one that does this kind of thing. And I think we'll have a new set of technologies that allow us to work more stably with these microbial populations and not have to pull up the carb on it and hack the genes. But because we're at the beginning of that journey, in this living architecture system, we had one section of the bioprocessor cascade that was a synthetic biology bioprocessor. And in that, these guys were just genius from the Spanish National Research Council. And essentially, they took the design of the microbial fuel cells, which was really made into a 21st century technology by work of people like Yannis Iropoulos, who's really made microbial fuel cells more technical in a sense that they're better spatially and electronically designed, and the materials are being explored. So using the, let's call it the hardware chassis of the microbial fuel cell, and then taking the technologies of synthetic biology, if we had one chamber that allowed light in, we could grow up a little population of microbes that could overproduce sugar. Now, this is like Charlie and the Chocolate Factory. These microbes just produce huge amounts of sugar. And that means that this sugar will pass through the semi-permeable membrane, let's call it on its first floor, and pass down to the lower floor, where different workhorse organisms are kept. I don't really like that word because it doesn't sound very caring. It feels a bit primitive in relationship to our future relationship with microbes. But the idea of the workhorse is that these microbes have genes that we know very well, and that means that we can rethink metabolic relationships using the gene libraries that we have. And so we could develop new metabolisms for organisms that didn't even live together. And so that these metabolisms were kind of shared. And that meant if one ran away, out of the apparatus into the wild type, it would soon shut its gene down because it didn't have the other partner to play with. So that was one way of thinking about biosafety. But what was really interesting was that although these microbes don't live together or like each other in nature, when you give them enough sugar, you can bribe them into doing whatever. So these microbes, like off their head with sugar, starting to make up metabolisms that just aren't natural. This system is kind of biologically crazy, but it's really interesting because you start to get a real-time view of what microbial creativity can actually be, and how we can start to negotiate with these creatures that are not only our deep ancestors, but they have an environmental intelligence that just totally exceeds our own. And I think that we kind of need to recognize just how genius these tiny little entities are, little agents. I mean, they're everything. They're material, they're technology, their body, their spatial synthesizers. Because a microbe transforms its environment in a way that not only creates its own home, but it makes homes for other microbes around it and other creatures. So there's a kind of generosity to microbial living that we could really, really take a leaf out of. And so, with this kind of design, spatially designed, metabolically designed, microbially inhabited, technologically supported kind of infrastructure, it became very interesting to think about, okay, so we're not dealing with industrial scale levels of product here, but there are some principles here that really feel transferable. And so the next thing that we did, and I mean, when I say we, I'm not talking about an imperial we, I'm trying to communicate that in order to get this done, a lot of people are involved, a lot of different forms of expertise, and there's a lot of work that really goes into this. And this is not something that you can do solo. So the idea then was, how do we actually negotiate with these microbes on a day-to-day basis? How do we know they're there? How do we know that they're doing well? How do we know that they like us and they're happy where they are, and they're not going to sneak out at night and cause trouble? So what teams did was actually think of the microbial fuel cell again, because one of the side products of metabolism in the microbial fuel cell is an electron. And you can capture those electrons with electrodes, and then you can use that bioelectricity to power equipment. But it's not just power. This is the smart thing about biology. When biology deals with electricity, it's not just talking about power, like in machines. It's talking about data. So it's telling you something about how that system is performing. And it's not just talking about power and data, it's also talking about material transformation. Because in the chemical realm, when you pass one electron from one atom to another electron, another atom, you actually get configurations changing. So proteins will change shape, atoms will turn different colors, they become charged in different ways and do different kinds of exchanges with their neighbors. So electron transfer in the biological world is associated with physical change. Let's say a conceptual conundrum for Enlightenment biologists who really separated information via DNA with metabolism, which was associated with body growth and change with time. So electron transfer and the kind of a whole bunch of electrical kit that biology has, really fascinating stuff. So, bioelectricity is a fantastic toolbox for redox reactions with ions, with electron transfer systems. There's an amazing tool set that is incredibly creative, and it works with this kind of parallel synthesis that machines just don't. So we've got our microbial fuel cell, we've got our electron producing microbes sitting in a little organized city or biofilm stuck right next to this semi-permeable membrane that's letting things come in and out, and so that gradients can be refreshed. And when the electrons are drawn off, we know that data has meaning. We don't know what that meaning is, but we are going to project a little bit here because we don't have much experience with this. So data artist, Julie Freeman, made a set of fantastic animations that were really reading, let's call it basic physical information like temperature, like pH, like the presence of certain ions, potassium, for example. And so by measuring those with ordinary sensors, mechanical sensors, and seeing how much electricity the microbes were producing, Julie developed a series of animations, and they're really cool, and they've formed a
Rachel's just dropped out. I think it's her connection, so I've just invited her back in. So apologies about that. I think that you can hear me. It looked like it was just Rachel's connection that dropped. If you can just put a little message in, if someone can just put a little message in the comments to let me know that you can hear me, because from where I can see, it's only Rachel's connection. It's not the main connection that's dropped out. Yeah. Okay, so we're good. So we're good. Remember that when Rachel logs back in, if you have any questions, then do send them, and I will put them to Rachel. I'll just have a check and I'll see if, yeah, you can hear me. Okay, brilliant. That's okay. This app is kind of weird because I can see you and I can hear me, but I can't hear anything else unless Rachel's talking. So hopefully Rachel's going to come back in. I'm actually just going to quickly bounce her an email just to check. Oh, she's unable to join. I'm going to bounce her an email to tell her what we can do to fix this. And I'm just going to say, she bounces me an invite. For some reason, she can't pick mine up, but Rachel only actually joined today. So although we're following each other, there's some tech problems with her account. An invitation to join, and I will accept to get you back on. Sorry, to get you back online. Here we go. So, brilliant. Okay, thank you, Audrey. I can see Audrey is saying, we'll wait, don't worry. Thank you for being patient. We are having tech issues today. It's my phone randomly had a tech issue, had to restart it, and we've had sound issues, and now Rachel's connections popped out, but we should be back online in a minute. As Rachel was talking there, you know, what really struck me, for those of you that haven't read Rachel's PhD, many people talk about paradigm shifts. Many people talk about creating, you know, genuinely new ideas. But one of the most impressive things about Rachel's PhD, which was now published quite a few years ago, several years ago, is the fact that she spoke to taking it back to the blank canvas. And for those that have been with us since the start of this conversation, yeah, few requests. Here's Rachel coming back online. You all know that this is genuinely what Rachel has done. She's genuinely taking the concept of the city. Hello, Rachel. Sorry about that. I think your Wi-Fi dropped out.
Oh, God.
Don't worry. Don't worry.
People are still
we had a comment. We have Audrey Rangalagire is with us today, the bio artist, and she said, don't worry, we'll wait, so it's okay.
Thanks, everybody. Sorry, I didn't even realize I disappeared.
Don't worry, you cut out just so, you know, as you were talking there, you know, what really struck me, and I mentioned this to those viewing, many people talk about paradigm shifts. They talk about, you know, creating new ideas, but one of the things that your work genuinely does is you really are taking it right back to the canvas. You are literally, it's not even back to cellular level. This is to the sub-cellular atomic level that you've stripped it back. And the other thing that really struck me is that, you know, although today we are broadly talking about the interface of human and non-human systems in cities, but actually when you strip it back to the level that you're working at, this is not just about the built environment. This is about the whole working of society, of how we structure our world. And, you know, what you're speaking to is by working with the microbial world, by working, you know, in effect with the subatomic world, you are actually creating a scenario in which you are systemically re-examining how we not only build, how we create energy, how we create food, how we effectively organize our utilities, the whole shebang, isn't it? It really is.
I think what's really important, you know, and this isn't just me at this time, I think it is important for us as a world society to have a narrative that we genuinely think is going to help us repair the damage that the legacy of the knowledge of people that have come before us have produced. And I don't think it's been deliberate. You know, a lot of this has been inadvertent, and then people get trapped within paradigms that they can't get out of because they become commercialized or entrenched in kind of cultural tropes. And I think it's really important that we take some time out And as you beautifully said, to think from first principles. I mean, the science that I went back to first of all was the origin of life. To think about how does matter become lively. If we don't have the answer to that question, but we have some insights as to how matter can become livelier. And that's important because that's a start. That's something that soil does. And soil's obviously one of those things that has been a catalyst and a technology and a material that's really been fundamental to the evolution of the biosphere. And so I think there's a lot of stuff that we've taken for granted because of the paradigms of thought that place us at the top of a pyramid of order. And therefore our knowledge of the world is also seen to be at the top, when in fact, actually, in terms of biology, we're probably somewhere down the bottom. I mean, as a species, we've not been here for particularly long. And so I think a little bit of humility and rereading the room in terms of not just saying, well, we've got it this far and therefore we're going to plow on, but actually opening up new possibilities. And I think the start of that is stories. And if we can think of a story that it needs to connect, it needs to feel real, it needs to feel like this is something that we can do and we can get involved in. This isn't just something for an overfunded billionaire to do all by themselves. This is something that every single one of us can participate in on a daily basis. And that's the level of empowerment that we need to be at. I mean, sustainability, kind of promised it was going to do that and then very quickly went back to the old marketplace with the same kinds of inequalities and infrastructural challenges that we've always had. So I really think that we are on the time out step right now.
Time.
The time out step, kind of, okay, guys, you've had your fun. Now, what's the actual plan? And so I think that these conversations between scientists and artists and designers and people working at different scales, people who work with living things on a day-to-day basis, and they care for them, caring for something, tending for a plant, bringing up a little cat or a pig. You get to know something about the living world in that relationship that isn't just in a textbook. So there's that kind of knowledge about being with others that I think that we really need to pay attention to and develop into our approaches. And that doesn't mean that we shouldn't be dealing with the intellectual and the mathematical and the technological. That's all important too. But we need a synthesis. And I guess the question that's on my mind is, at what level does this synthesis start to take hold? And I think that working at the human scale is probably not the right scale of order. The 20th century taught us about the quantum realm. And I think one of the magical things about the electron that we've learned from the rise of the Industrial Revolution and from the advances in quantum physics is that the electron is both a classical and a non-classical entity. So in biology, the electron can be a form of electricity, and we think about the nervous system, for example, or Galvani's frog dissections as the first example of the animal electricity. But also we can think about electrons as forms of entanglement. So, for example, the European robin has, in quantum biology, entanglements at the back of its eye with weak magnetic fields so that it can see magnetic fields as it flies. So it knows which direction to go. That's incredible. And we didn't think that biology could do that at the start of the 20th century because physics was the dominant order of thought. And as biology became more empowered through developments in physics and chemistry, through molecular biology, these principles could then be explored within the scientific realm. So the rise of quantum biology in the 1980s, I think, is absolutely revolutionary, but I don't think many people know about it. And if you do want to know about it, I would go and look at Jim Al-Khalili and John Joe McFadden's book. It's Quantum Biology. I can't remember what the title is. You know, it's got a very short, little, catchy title, but it's a fantastic account of the controversial developments in biological thinking that have been set by the quantum mechanics. But what that does, and this is important, and this evades many of the traditional narratives that we hear about biology, is that it makes biology weird, right? It means that biology can do stuff that we don't predict, that we can't actually explain. It really kind of helps us understand the idiosyncrasies of the living realm. And in that sense, you know, what we think is the real is actually surreal. What we think of the natural is the supernatural, because of this entanglement. It's not that all of a sudden everything, you know, is strange and we don't understand anything. That's not it. I think where these worlds connect is at that level where these there is a dance between the quantum and the classical. It's at that kind of level of order. And I think that's why molecular biology is starting to show us interesting stuff. And I think it's only possible for us to see this and understand the advances when we have minds that are curious and asking questions, even when we don't know the answers. I think one of the most fantastic minds of the late 20th century was Carl Wohl's. I don't know how many people know about his work with molecular biology, and he was the scientist who discovered a new class of microbes called the archaea. And what an amazing discovery, because, like, you know, since Carl Wohl's, we've been able to tell new stories about microbes. And the beautiful thing about archaea is that there are no pathogenic species of archaea. Why? Because inside, they're really like us. It's so weird. These are like little microbes that look more like us at a subcellular level than bacteria do. And it's, you know, Donna Haraway talks about this, you know, one microbe eating another and it gets bad digestion. And then you get the symbiogenesis and the formation of eukaryotes. And that bad digestion is us. It's kind of got the best of the Archean world, which has got this kind of cellular creativity, structure. That's what the archaea gave us. They gave us structure, whereas the bacteria gave us metabolism. So bacteria remain the masters of metabolism. Nothing will beat a bacterium for the power of metabolism. But when you bring the archaeon's ability to build structure into its proximity, you start to get the traces of the world that's big like us. And so I think it's at that junction where the prokaryotes come together to create this incredible platform for new biological possibilities. That's the level where a very interesting conversation takes place. And there's another one that is happening at the quantum level, but we simply don't have the language for that. We don't have enough tools that will help us view events and be able to see them differently. And that's what Carl Wohl's was able to do. By using the tools of molecular biology, he could see the insides of a microbe differently. And that's important because up until that point, microbes were judged just like we judge ourselves by according to their beautiful forms. So our prejudice in evolution is that form is the governing framework through which we evaluate everything. The microbe they go, what are you talking about? It's metabolism. It's your ability to stay protean. It's the ability to connect with your environment in such a way that you could survive anywhere. And so the microbial realm has still prioritized those fundamental, almost existential kind of biological tricks. And so there's a huge amount of knowledge that we have yet to reach into that. But I think, so WOS, I think, shows us a realm of new stories. It's challenging notions about human identity. So if we arise from an archaeon, getting indigestion from eating a bacterium, then if we go back to Bishop Wilberforce's kind of debate with Thomas Henry Huxley at the Oxford Union Society, and we have ladies swooning in the gallery because there is the suggestion that we may be descended from apes, then just imagine how much swooning there could be if we were descended from slime. You know, the kind of the radical re-envisioning of who we are, and that we, maybe a bit like my imperial and team-based MeWe, is really a collective, and a collective that has a kind of a very deep story, geostory. And so that when we think of the human, up until, let's say, the 1970s, when Carl Woese, and then later in about 2010, when this theory of about archaeon meets bacteria came out, the idea of what a human is has suddenly, now up for grabs. It's up for grabs because not only are they written into our DNA and whatever this stuff called junk DNA is in there, but also with the microbiomes. So, the human, previously a machine, may be now much more holobiontic in terms of its kind of structuring, in terms of a kind of, let's call it an attractor, a cellular attractor that is mainly produced by a system of human DNA, but is absolutely made possible and augmented by all kinds of other species of DNA, mostly microbial. And that's really very interesting, because then when you ask, who am I, we're asking, who are we? And then what is our responsibility to our microbes, which we've just been squirting into our living architecture bioprocesses. And, they're going to go through a second pass, and I'm going to touch the walls and I'm going to distribute them around my living space. And all of a sudden, I wonder what my environment is as well. How independent and autonomous can I be from the space that I'm living in? And so I think there are by rethinking some of these existential principles, I think it gives us a view about value, and with value, the things that we care about. Because if we are, if we want a healthy, happy life, we need to look after ourselves. But rather than just look after ourselves and everything else goes, we actually now need to look after our microbes. We need to look after the microbiomes in our room. Oh, maybe we need to look after those in the city as well. And if we look after those in the city, gosh, how far does this actually go? And then when our bodies travel through all these spaces, we're contributing to our kind of microbiome topologies. And Jessica Green, who's a fantastic TED Fellow, or Senior TED Fellow, she set up a new company called Phylogen. It's amazing. She was the first person who showed me that the microbiome existed, and she was working at the University of Oregon then. But she set up this company called Phylogen, and what it does is it's a database for tracking microbiome data. So in other words, you can get a value on a product line and find out where it's been, its carbon footprint, by looking at the microbiome it carries. So it could be used in forensics, it could be used in kind of green marketing narratives, looking at the footprint of things. It could be used to identify something as being genuine or not. So so all of this is interlinked in a sense that once we have access to some principles about how these spaces are ordered, then we can start to imagine what the opportunities are there, and ask questions about how we start to create the best kinds of relationships with these invisible fabric that first of all were a source of wonder in the 16th and 17th century, then became demonized in the 19th century with Pasteur's view of kind of the germ. Yeah.
I mean, it's
so,
right.
and then we went to war with them, and then we kind of got slapped around a bit by antibiotic resistance. And so I think we're sitting on the naughty stool again, having a think about that too.
Absolutely. I mean, I see parallels, when you were talking about the form versus metabolism, that exactly is an analogy for the resilience versus engineering dichotomy within environmental resistance, in that we know that the more engineered something becomes, the more effectively engineered any sort of system becomes, the more vulnerable it is when something goes wrong, because as you know, if you throw a spanner in the works and it's highly engineered, then it will break down very quickly. Whereas when you've got the systemic approach, when you've got a more distributed model that is less engineered, then that is, certainly with environmental system science, much more resilient. But actually, I was also thinking about what you were saying and health, because obviously one of the big areas of advancement in that particular domain is understanding how the immunity system works, understanding that, for example, the relationship between viruses and cancers and much more serious diseases, understanding that, when you get even obviously COVID has partly advanced this, but, the research around that, but it was a big area before that. We're now understanding that when people get what might seem a very minor virus, they might not even be aware of it. That can then develop over time, and we obviously don't know exactly what's going on, but we know that the immunity system response has a huge amount to do with that. So again, when you're looking at the sort of the edge, as it were, of health science and of understanding how we not so much necessarily avoid death, as it were, I'm not sort of talking about extending the duration of the human life, but certainly about how we keep the quality of life and how we keep people really fit, healthy into their late years. That is all systems based, and it's absolutely tying in with what you're saying about understanding these unseen things, these things that we were completely oblivious to, that now we realize, be it a virus, pathogen, nanoplastic particle, all of these factors actually have an enormous impact over time, cumulatively, on your health. So, it feels there is this enormous synergy across the sciences, and almost like in the Renaissance or the Enlightenment, this is, isn't it? It's all sinking in here.
It's generally a resetting. I think that the prevailing order of capitalism, neoliberalism, the fossil fuel industry, the Victorian infrastructures that have done very well thanks by kind of creating a system of scarcity on which we are completely dependent. They will resist these new forms of discussion, because I think there is a new economy here. I think there are microeconomies. I don't think they're all based on symbolic goods, that some of these are actually material transactions, almost like we were back at the marketplace, but not a marketplace that develops according to profit and loss, but is a kind of trading between neighbors. In other words, it's more like a commons than it is a system for exploitation or kind of accumulation of resource beyond what anybody could use in a lifetime. And I think that the living world really shows us some of these principles as a kind of a function of the persistence of life on this planet. It's not even an ethical debate. It's a kind of it's a function of the physics and chemistry and the kind of elemental systems that enable life to persist. And when we trash those, we're just tearing holes in our own fabric. So we can have whatever ideology we like, but I think that the living world is really showing us what hangs together. And in that sense, if we can reset our thinking within the carrying capacity of the planet, or whatever we call that space of possibility in which we can have a lot of fun. I don't think this is about, kind of doing without. I think that there is a great deal of consumption that goes on in the natural world, but it's done within a transactional system which allows other forms of economy to coexist. So you can consume as long as you don't just take it away from use by everybody else. And so it might actually be that people that consume a lot are actually hubs, attractors. They're attracting lots of life towards them. And so, there's a certain amount of consumption that actually becomes catalytic for transformation and the diversity of different kinds of coexistence. And I think it's a really important principle. So we've demonized consumption per se because it's been put into this framework of profit and loss and accumulation by a very few, rather than something that's actually actively shared, but is returned by a living community. And so that's where I think that this idea of if we can activate the commons through these narratives, through these systems that are transactional, that we actually get into an environment where we're sharing, where consumption is actually a form of sharing. It's like eating together, and then we kind of clean up the waste and we put it into compost in the garden, and we go out and we sow some tomatoes and lettuces for the next time we sit down together and have a great meal. It's that kind of idea that there are cycles of intake and excretion, and that is actually the flow, but it happens within limits. And I just think that we do need a great recalibrating as to what's important and how things can work. And we don't need, lobby groups and big oligarchs and vested interests from corporations involved in this. I think this is something for ordinary people to talk about. And I really think it starts in the home and the gardens that we have access to. So a lot of people don't have access to gardens, or not even public gardens. I mean, I just think it's a great crime that the things that we share, the commons is no longer in our common conversation. The individualization and mine has become the be all and end all of our transactional systems, and that there's a certain amount of generosity that we need to coexist. Because the microbes have shown us that we are not an island. We're not just a pure human. We're actually made up of many other communities. And we contribute to many other communities. And our thinking needs to readjust to that. And without the commons, we are really imprisoned in a very narrow set of choices. And we're being forced into situations that we know are bad for us, but there's nothing that we can do about them. Well, that's how we feel. And that's why I think, sitting on the naughty stool is quite a good place to be.
I've just seen a question actually from Nicola, and she said, I was wondering if you could reflect on what pronouns to use when referring to microorganisms and other organisms other than ourselves. What are your thoughts?
I think it would be great to play with some. I mean, the we is the one that's shooting out of my mouth at the moment. But I would love to play with some pronouns, because there is a holobiontic we, there's a commensal we, there's a symbiotic we. I mean, there are lots of kinds of we, and in English we don't have a lot of different kinds of we. So I think it's a great.
Yeah, and I mean, that is one of the things that I think a lot of people forget, is that languages vary from not only one place to another, one time to another. There are many, many different systems of communicating information and of encoding it. And that for us has been a big problem, because when we think about policy, when we think about the overarching regulations by which we all have to live, we either, abide by these rules and the way they're inscripted, or we might end up in prison, putting it bluntly. the way in which presently that information is delivered, it's very much siloed, it's by section, it's by the subsection, and it's not really, well, it's not even fit for the current organization of our societies and cities, let alone what we're speaking to here, of actually really taking this back, as you say, to first principles, creating from the bottom upwards, wherein everything becomes integrated, and we have this awareness of these very, very subtle changes that really every single action that we take, as you were saying, you know, you put your hand on the wall, it's carrying microbes on it. How is that going to affect the microbial community in there, and so forth? You know, we simply don't have that now. And so, you know, this is something that is literally, it's a lateral shift we need here, because we can't enact one area of change unless we're actually reconfiguring everything else, isn't it?
And I think what you said is very interesting, because it's really changing paradigms of control to paradigms of navigation. Because navigation is, we're still trying to discover the terrain in which we exist, whereas control is that we've already set the order, so that hierarchical order that was set in the Enlightenment. You know, and I think that we did try to de-hierarchize it with systems, but the trouble with systems is that they're not material, they're symbolic. You know, when you see a systems diagram, there are loads of different lines. You know, if you look at the kind of biochemistry of a human body, you look at all the different lines about where all the different bits go, and it's a kind of metabolic system. I don't know where to start building that. So the system doesn't really have, you know, the way that we draw systems, and I'm not saying the system doesn't exist, just the way we draw systems is not particularly spatial, it's not particularly material, and it's not really temporal either. We can't really get all that data into a system that really encapsulates what's going on. So it becomes rather gestural, and it's not really helping us make actual decision here as opposed to there, and how we get those two to talk. And again, I think this is because, you know, the conversations are only really just starting, and with that, different kinds of information are kind of entering into our conversations, for which we are poorly equipped with the language that we use. But yeah, definitely, I think that we're going from a system of ordering and hierarchizing and sorting and giving everything a fixed name, to a navigational system where we are really looking at the relational aspects, we're looking at spatial aspects, and we're looking at temporal aspects in a way that previously we've been able to ignore because of the frameworks that we've used to kind of be in the world.
And, you know, the other thing I was thinking as you were describing the research that you were doing is the fact that for many people, I mean, as we've seen, sustainability has effectively been co-opted in some respects by some aspects of the corporate community. It's being packaged up, it's being, you know, sold in a way which in many ways, you know, things like carbon offsetting, you know, is counterproductive to the overall aim. Some of the ideas that, you know, you're speaking to may seem incredibly big, but I thought, you know, one of the things that is happening at the moment is we are seeing, as it were, mass scale collapse of societies and cities. It's coming in from the perspective, you know, we're seeing massive flooding events. There was the glacial flood over in Pakistan, where, you know, we saw, and we've seen this in India and Asia more generally, you know, where we've seen huge communities literally wiped off the map. We're seeing it, you know, in terms of the wildfires, literally burning, you know, some urban developments down to their foundations. And now, of course, we're seeing it, well, we've been seeing it, you know, over the centuries, but particularly the situation in Ukraine, we are seeing entire cities razed to the ground. Even the heritage buildings, it seems, are just being knocked out, like, you know, just sort of tossed away. And so we are seeing the canvas stripped back. And, you know, it strikes me that obviously none of the people that are coming out with these, you know, and developing the sort of really radical ideas, the things that are back to first principles, would obviously want this to happen. This is not, you know, part of the vision. The hope would be that you would have a much more comfortable transition. But as it happens, you know, this is happening. So it does actually create, if you like, this space where the things that you're speaking to could potentially actually, you know, breathe, they could have life, they could actually emerge over the coming decades. What sort of sites have you seen the things that you're working on developed in? I mean, do you see this as being a very distributed model, or do you think there is the possibility that when we have these enormous spaces effectively raised to the ground, potentially those could become the locales for, if you like, mass experimentation?
I think we need mass experimentation. What we're getting is a lot of resistance. I mean, even now, I mean, the adage that the marketplace has to drive this is really nauseating. You know, so I love the European Union, but the neoliberalism in it is really, you know, some ethical decisions about what kinds of technologies we want need to be made at a political level. It can't just be left up to the marketplace and the next unicorn to decide. I think that we also need innovation for the commons, not just for businesses to make bigger businesses and then multi-corporates and then, you know, kind of drive GDP that way. We need tools for innovation within communities, and we need those available to people as, I'm not going to say cheaply, but as available as possible. What I mean by, I don't see this as a mass market thing. I see this as being artisan-led. I see this as being people caring about a place that they live in and investing part of themselves in this innovation. So I think this isn't just about a fix. This is about changing strategies for living that becomes culturally emplaced, that becomes maybe specific to certain kinds of sites, but becomes the empowerment of that particular community. And with that, then there will be markets, there will be, you know, ways of trading and exchanging. But I think we really need to invest in empowering people at the level that they can respond when the flood comes, and they can have fresh water and basic sanitation and some light. And they don't have to wait for the government to send the rescue team in, because they have that basics. And we don't have that. We don't have it in the Western world. God knows, you know, the poor people in developing countries, I mean, you know, it makes me mad. But I think it is really about starting with the home. We keep innovating for cities and businesses and products and, you know, kind of big solutions and, you know, geoengineering and all this kind of thing. And I really think that let's do something very simple. If we could all transform our homes into sites that only used 12 volts, like a camper van, and if we could find ways to do the things that we like doing every day and the things that we need to do, using 12 volts, the impact of every single home on the planet will fall precipitously. And not only that, if we use something like a microbial fuel cell, we're not putting the wastes directly into our waterways like we currently do. We're processing them at home. And it also means that with these microbial fuel cells, you mentioned something about the immune system earlier. And actually, when you cohabit with certain microbial biofilms, they actually become like an immune system. They police the bad agents in the water. And so the Yanis Iropoulos and his team showed that if you recycle wastewater through microbial biofilms, they'll remove hepatitis B from the water. It's not been tried with COVID, but a home with a microbial population that knows what healthy bacteria on your bodies and microbes in the environment are, they're the ones that are going to look after you. And if we think about the last revolution for dealing with microbes, it was antibiotics, which was not invented by humans, but by fungi. Yeah. So if we're actually using microbial intelligence to help us navigate other microbial challenges, I think that's the kind of level of solution that I personally feel quite comfortable with. And that's not to domesticate microbes. I think we have to treat them a bit like wild animals. You know, we can't we can't take them for granted. I think it is really, you know, Bruno Latour's notion about Frankenstein must learn to keep on loving his creation, because, you know, when he doesn't care for it anymore, that's when the relationship goes really badly wrong. So, you know, we're loving our creations, as it were, and I don't necessarily mean we're inventing Frankensteins. It means that the things that we are immersed in, that we're actually involved in, whether we want to be or not, we have responsibilities. So I think at the grassroots, a 12-volt lifestyle, it is perfectly possible with some of these waste recycling technologies. I love the microbial fuel cell because it produces bioelectricity, but there are also biodigesters that will produce biogas. If we're doing this on local basis and we're using this sparingly because we've got 12-volt limits to our consumption, and we know that there are plenty of electronics in the home that don't need 12 volts.
Yeah.
You know, we need a much smarter way of using energy, just like microbes do. They don't take in huge amounts of electricity, go, well, we'll scale it down because we only need one electron out of those 100 that just arrived. You know, we can actually use the microbial systems to power artificial intelligences that are telling us who needs what, and actually being able to divvy that up before you know, we're even aware that we're using any energy. So all of these things that we call smart right now are really quite dumb, because we've got supernatural kind of quantities of energy that don't do anything other than blow things apart. Whereas if we had much lower energies, we'd have that triad of let's call it biological electricity. So power, data, and chemical transformation, but it only operates within a limit. If you throw 230 volts at it, it will die. And it only works when you kind of put your paddles on your chest, or you kind of fry somebody's head with ECT, because the system is out of kilter and it's a kind of a temporary shock. But if you keep that up, you're definitely going to stop things working. So I think that we've had this idea that power can solve every single problem, and we've innovated like that. When we've innovated for cooling, we haven't looked to materials. We've looked to, oh, how much power can we throw at it? Because there's loads of power around. If we look at heating, oh yeah, loads of power around. We haven't looked to very smart forms of insulation and the strategic use of different kinds of materials, or even the natural flows of you know, gases and heat through spaces. There's not enough invested in that. It's not to say that people haven't done it. It's just not something that we naturally adopt. And if our homes were more like bodies in that sense, kind of going back to my medical background, you know, we think about the physiological flows through a body, and each body is slightly different. You know, we're not all carbon copies of everything else, but by living in a home, you can fine tune all that. And if we have the kinds of environmentally embedded sensors called microbes, they can help us understand a lot about what other things we might need to do or select or change in how we're living. So I think we can take steps. And I think the first step we do, let's have every single home running on 12 volts.
Yeah. Yeah. I mean, as you were speaking there, I can see we've got a couple of questions, so we'll get back to those in a minute. What I was thinking, so throughout the series, for those that have followed it from the start, so we started off the very first BioFutures conversation on Instagram. We had Claudia Pasquero and Maria Kapsova. And in that conversation, we were talking about introducing the algal systems into our homes for food, for energy, for cleaning the air. We've had Full Grown. We've had Gavin and Alice from Full Grown, who have a furniture orchard, growing chairs and various other furniture items over a 15-year period. And what we were speaking about there is that although the process of actually growing furniture, although it's incredibly robust because it doesn't, you know, its joints are, as it were, fused, so there's no, you know, it doesn't break as easily as conventional furniture. But it is actually quite tricky to actually grow the furniture, in that, you know, you have to really understand how to nurture the trees, and they're grown in a special, sort of grown upside down and using all these various techniques to make them what they are. Although it couldn't work at the level of the house as such, it could work at the community level. So Alice's vision was that we utilised the sort of redundant spaces, things like the side of motorways and road verges and things like this, for orchards, for furniture. And the wonderful thing about that was that they've discovered that you can actually, it helps the furniture orchard to have other things growing. So you can actually have food being grown. And they found that actually, you know, the wildlife, you know, pretty much utilizes the furniture orchard as it would a normal orchard. The fact that the trees are upside down doesn't really bother them. And so we've got growing our furniture. Then we've had who else we had? Oh, we had Rachel, another Rachel. We had Rachel Horton-Kitchloo, who has developed home fungariums, and so that you can grow, you know, fungi. And she was saying that actually, when you're composting with fungi, because fungi is very selective about the nutrients it uses from the compost, you can pretty much throw anything in there because it's, you know, it's being pretty picky as an eater, to quote her words. And so now I'm thinking, you know, we need the microbial fuel cell and we need the biodigester in the home or in the locality. So this really is an ecosystem, isn't it? It really is. We're looking at the emerging, well, in some ways it's not new, it's kind of going back to the origin, as it were, but this interrelated system of things that, you know, we are having to nurture, we're having to care. I sometimes would use the word garden. Do you think the word garden is the right word, or would you use another word?
Yeah, I think gardening is a practice. I wonder though, I like the community better because it's a multi-species community, and if we saw our furniture orchards actually as beings that, you know, had a certain status and you know, respect, rather than, again, I think that with the gardener we place the human at the top of the pyramid, and I do think we'll benefit with a little bit more horizontality in our relationships. You know, we manage it for pets, so I think we could extend that. But I agree with you about the relationship between the home and community. For me, that's the difference between the household and the commons. Not everything scales to the household. Some things are much better in the community. I would say that the processing of human waste is definitely a community thing, and that I think that you could really optimize strategies for processing that resource and transforming it into redeployable goods that can then have a communal decision about where they're needed. So I absolutely, you know, this is about living together, and the kinds of contracts that we set up in terms of caring for the world and being cared for by all these investments. A bit like the way that you know, kind of microbial biofilms participate in their own set of transactional goods to maintain stable within their, you know, highly protected but highly productive sites. So I think this is absolutely right, that the cohabitation between humans and non-humans through varieties of different species and a variety of different caring. So I think you know, the relationships that we set up, I think is key to this. And I think we do need the associated change in language, because that will help alter our thinking.
We've had a question effectively about how do we approach city leaders and other citizens to start a conversation at the city level about using microbes to replace electricity generation locally? What do you think?
Demonstrators. We're really trying to build them at the moment. That, you know, there is a certain level of expertise, you know, to make something really effective. It's a bit like, I could build a chair all by myself. I would probably be well advised to get some help. But you know, so these microbial fuel cells, actually, the IP on them, you know, dates from 1911 was the first time they were used. So there are protocols you can get on the internet, and there is nothing stopping you from, you know, trying to do it yourself. I think what we need is some really great demonstrators where we get the creative community involved and we think about what, so we can do it as a kind of vernacular exercise, showing what we can do in an allotment with a bit of know-how and this internet search. But I think it would be really great to see the kinds of artisan community showing, glimpses of a lifestyle that's actually really cool. And requires these other things, and that we're aware of the I don't like lifestyle. It feels like a kind of commodity, but the investments that we make in return, there's almost like we need new contracts for the spaces that we live in, because it's not because we're at the top. We kind of have to acknowledge the investments that we're making by being a body in a space, and we need to appreciate the things that we're getting in return. And in a sense, Linnaeus was doing that. But he was taking stock of God's household, but he was doing it from a completely anthropocentric perspective. So if we did it from and I know that we can't totally not be human, but at least the attempt to think into or in the words of To Kill a Mockingbird, to climb into somebody else's shoes and walk around in them for a while is possibly what we need to try and do. Try and adopt some of these other perspectives, knowing that it's incomplete, but that's why we do the experiment. That's why we kind of run the sets of relationships and remain observant and don't think we have the answer, because I think we'll never have the answer. I think this is always, just like microbes have done for the last 3 billion years or so, they have always stayed in contact with their surrounding and read the room. And that's the kind of investment that we will be making. So how do we convince them? We show them demonstrators that are just so damn cool and that people get excited about them, and people do get excited about them. On paper, industry doesn't, because they go, oh, well, that's just a battery, isn't it? And why isn't it doesn't produce as much as a titanium battery, does it? No. Well then. That's about as far as it goes. It does water. It does data. It does environmental bioremediation. What more do you want? I don't know. We're only it's like, oh. But a demonstrator shows the creativity and the will of people to work with something that may not be perfect, but because they are determined to find another way, that they become part of that innovation community. I really think that we need that. We can't just have innovation down to a bunch of capitalists that just plow it all back into more capitalism. We've got to break some of these fundamental, as you said, Melissa, right at the fundamental level. We need some experiments like that. But if we can make it look and feel great, that's going to be more persuasive than a lot of paperwork, a lot of, let's say, profit and loss calculations.
We had a fortnight ago, we were joined by Andrew Grant, the lead landscape architect on the Gardens by the Bay, and he was saying that the government of Singapore, they really have the vision, they really understand that they've got to invest in this, but also that the value of ecology and the value of taking that systems-led approach. They have created what I think you could call a number of demonstrators. I mean, the Gardens by the Bay has outperformed the original spec enormously, and not just in terms of the footfall and the engagement, but also in the fact that it itself has been an attractor. It has brought in new projects, it's brought in energy. I said to him, it's very much the Gardens of Babylon of our time, in that it is so spectacular that it's bringing people want to go to Singapore. It's changed people's perception of Singapore. And when we look around the world, I mean, I very much agree with you on the demonstrator, because the fact of the matter is, not only does that show people tangibly, what it looks like, but it also really helps to cut the wheat from the chaff, in that there are so many proposals that, as a scientist, you look at, or as someone with technical expertise, it's not going to work. You can see straight away, right at the level of biology or chemistry or whatever it might be, it isn't working. Well, usually it's not working on not one but several fronts. You can see that because you can think in that abstract sense, because you've got that technical knowledge. Many people can't, but because it's on paper, it isn't tested. And so, I think when we look to the media, when we look to magazines, when we look to the conversations that are going on, a lot of it's very superficial work. When you've got the demonstrator, you can smash right through that, because you can actually show, right, first of all, what stands up. And then, as you say, you can enable people to step into that alternative world and to really imagine what it might be like. And I will give you an insight. I have actually been speaking with some investment communities, trying to get them to put the funding in to afford spaces just like this, where we bring out the very best pieces, where we have experiments. Because what I'm finding is that the investment community, I think, you know, they're listening, they're interested, sometimes for the worst of reasons. They want to make money. But one of the things that often comes up is, because this is so alien to so many people, if you're not working in this space, if you aren't seeing and familiar with these things, they seem to you a little bit weird. And that for them is it's a difficult thing. You know, they're not comfortable with it. But you put it in front of them, you let them touch it, you let them smell it. That's a different gig. So I totally agree on the demonstrator front. I know that certainly there are some governments that are doing this, but it is nowhere near enough. But again, one of the projects that Andrew Grant mentioned in our session was the fact that there is, certainly in the UK, there is a new body that is trying to move towards creating more of this stuff. And, you know, as she was saying, at the level of the EU and around the world, we really need to see change, because what there isn't a lack of here is money. I mean, if we look to what's going on in the Middle East, we see countries like Saudi put massive, mind-blowing amounts of money on the table. But then, because of the process and because of the way that it's organized, I mean, you know, it's not actually developing, it's not actually creating these workable solutions, let alone things that actually can inspire people in the way that, you know, what you're speaking to here.
I think these capitalists have just totally underestimated the power of love. I mean, you know, and I don't mean that in a frivolous way. I mean that people actually care about nature. And I think that when people have access to a solution that brings them closer to the natural world and the living world, and they actually feel it in their bodies that something's happening here, even if it's not entirely perfect, even if it's not making huge amounts of profit, they want it to work. That's exactly what kept the NHS alive for so many years. You know, the NHS has been in peace for a very long time. But when people actually want something to work, they want to live there, they want to be there. City of Venice is another example. When you fall in love with something, you give it everything. And that kind of space, that connection that you have with the it's the hope, it's the proximity to something that you feel yourself is transformational, and you want to be part of it. The innovation crowd, the people that are looking for profit and money, they can't see that. And I think that what you get when you do work with communities, when you do you work with students, you get a sense you've entered into another dimension of commitment and care, and you see it and you feel it, and you know it's going to work. You know it is, because you have people with you, and that's absolutely priceless. But you can't kind of communicate it in the terms that these innovation pitch sessions oblige you to follow.
Yeah.
So I genuinely think that people, you know, if we have these demonstrators, I know what will happen. Kids will run around, bomb around, stick their fingers in things, you know. Daniel, I mean, they just do that, you know, and then stuff happens that you didn't expect. But like at the end of the day, everybody's had a really good time. You know, stuff surprised them, stuff didn't work, stuff was great, and they'll come back again, and they'll come back and invest some more time in that. And it's the time, you know, because a different way of thinking and being requires time. It requires you to stay. Donna Haraway's staying with the trouble. It's not easy, but if we love it enough, if we want this enough, if we believe it enough, if we feel the connect, that we know there's something there. We don't know what it is. Maybe we can't articulate it in the most communicable way, but we feel it, and I think we need to listen to that, and I think we're not.
Because, you know, I mean, I think it's wonderful to see. I know certainly within the futures community, we're seeing a lot more speculative fiction, speculative design, fictions more generally, we're certainly seeing that the spaces where we can actually imagine these new futures are definitely expanding. There are more people engaging. There's much more work being published, which is fantastic. But to the same extent, if we don't have those places that actually show, you know what, that this isn't just a science fiction movie, this isn't just a novel, this really is a solution to some of the most critical problems we face, and that we actually don't have much time to sort out because the speed at which this is culminating, you know, to create that perfect storm is really very fast. I mean, I think we're at that point now. My sense is that probably within about 24 months we will see some quite significant shifts, but you know, it is worrying because, as you say, probably I'd say my major concern now, it's not the capacity of the scientific and the artistic and the design and all the other intelligent and creative communities. I know that within that community like you, because when you look at what's happening, it's all there. The problem is that we do have this massive amount of resistance, huge resistance to change. That's being expressed politically, that's being expressed commercially. And I have a fear of, you know, some of the things I'm seeing, some of the patterns, for example, when it comes to even the sort of biodisciplines, the biodesign and so forth, is we're starting to see, for example, gender biased investing. We're starting to see projects that are led by men get more investment than those that are led by women. We are starting to see the same kind of treatment that we saw of people like Elon Musk and, you know, the Bill Gateses being turned into these sort of heroes to some of the individuals within that community. And actually, as we all know, everyone that is really playing an important role is part of a team, and that team is part of a bigger team. And so when you start to kind of create the star architects, it's problematic, because that's not how it works, is it?
Absolutely not. I mean, I personally, I think we need to fall in and out of some beautiful new worlds. And I think that they are at the local, the small, the kind of very personal level. I think that the demonstrators for me are kind of small and beautiful and magical, and we don't possibly fully understand how they work, but they're attractors of some description. But I think that those worlds are also microbial. I think that, you know, we need to pay attention to the possibilities that are being revealed through a rereading of the foundations of the biosphere. That's really what's telling us, you know, where the limits of possibility are. And I think it's helping us recalibrate our investments, you know, both on a very personal level, but also in terms of the spatial levels. You know, how far does our attention reach? How far can we manage these things? I mean, there's no point if it's, you know, we're requiring so many technologies that we can't develop portable principles that are applicable. You know, we need to stay with these spaces long enough to be able to find the protocols for kind of spatial engagement, new materials, technologies, you know, get an instinct for what this particular kind of world requires.
I'm almost picturing, as you were speaking there, about a sort of, in days of old, in the Victorian times, you'd have circuses touring, which, though, you know, for the animals were extremely cruel, and we certainly wouldn't want to replicate some of the atrocities and the bearded ladies and all that. We wouldn't want to do that. But I'm always thinking, you know, what was, you know, what attracted people to the circus was that it was a place of wonder. It was a place where you saw these extraordinary things. And I'm almost sort of picturing a demonstrator that's like a bio circus. It's this sort of tent of wonder that pops up around communities and actually shows them, you know, examples of the things that you're speaking about. Instead of the flea circus, you've got an exhibit that shows them something even smaller than that, that actually shows them the microbial community. The ringmaster is the person that explains to them how this is all working together, and how, you know, they are part of this event effectively that is taking place locally and globally. I mean, you know, I'm thinking there are so many things that we could do with this, and that would really help to sort of catalyze that the imagination, because I think we haven't got a problem of people not wanting to address climate change or to address biodiversity loss. People are very, very concerned about that. We have tangible, clear evidence of this. We have the major demonstrations. We have, you know, every company, every Tom, Dick and Harry organization has got a sustainability manager, director, now CSO. It's not a problem in terms of awareness that we need to do something. It's a problem in terms of awareness as to quite what the options are here. And, you know, as I was saying, for many people, the sort of things that you're speaking about would be wondrous and incredible to know about. But at the moment, they are remote for many of them, aren't they? They're remote, you know, no matter the TED Talks and everything else that's there to get it out there, we still need many, many more spaces to communicate the work.
I'm all for the bio circus, Melissa. So when you set up your tent,
yeah,
I'll be there.
Yeah, definitely. So, Rachel, we've got two questions that I'm asking everyone in this series. The reason being that they're going to be collated, so they're going to come together so that we can compare and contrast. Everyone who is watching and engaging can also, please also send your answers to this. You don't have to send them now because I'm not going to be compiling these for about another 3 weeks. But your first question, Rachel. So the year is 2050. What does this wonderful new future that you're speaking to look and feel like?
It feels very similar to the one we have domestically. Industries have changed. The reason it feels similar domestically is because we're able to do all the things that we thought we needed to do to live a healthy, happy life, but now we do them with microbes. And the microbial infrastructures are completely invisible. We pay no more attention to them than we would our boiler. You know, maybe we get the repairman in, you know, once every 3 years to give it a health check, but we don't really need to think about it. So home's fine. Where we go to work and what we do during the day, that's different. We're not working with machines as such. We're actually working in biological spaces. So there's a bit more green space, but maybe that space isn't just a big green space. There's microbial green space. That may be up and down the walls of homes in cities. It may be in derelict sites. These might actually be new kinds of zoos and parks where we're looking at soil zoos and really starting to see an expanded tiny world around us, which is still a site for wonder, maybe even touring circuses.
Maybe even that.
And then when it comes to industry, actually, it's very distributed. We've still got lots of makers. We've got furniture being grown along highways that are now actually only frequented by a low power rail-driven load of kind of supply goods from town to town. But so I think, and there's a lot more kind of public transport when we travel, but not huge amounts of heavy guzzling fossil fuels. And that slow travel is the thing. So we are moving. There is assistance for those with mobility challenges, but we just take our time. And maybe in 50 years after that, I would like to see us freed from bounded plots owned by landlords. I would like to see nomadism as a frequent part of the city, because our microbial infrastructures can come with us. So if the floods still come because of the legacy of the people that lived 50, 100 years ago, then we can move our dwelling. We don't lose our home because we're not bound to that rented piece of land, or which has been given over to infrastructure. We're able to release that to allow nature to help us buffer, you know, this incredible change that we're going to face with the climate. But we will move. We will not die because we are fixed to the spaces that we can afford, and we will not be condemned by greedy insurance companies. So I think that with climate change, we will see nomadism, but we need the infrastructures to come with us. So I'm not going to say it's a paradise. There will be nice looking homes. There'll be things that are really kind of cobbled together. There'll be luxury environments, you know, kind of like the odd Miami. But infrastructurally, we will be free.
That's a very beautiful vision you've got there, and that for the better part of our history was how it was, isn't it? You know, I'm thinking here to Mesopotamia and to the fact that, you know, they would regularly, the floods would come. Obviously, it's between the Tigris and the Euphrates. It would flood. They would, you know, the city would effectively have to be reconfigured. They had an avatar city, and so, you know, for them, although the city physically was gone, it wasn't gone spiritually. And, you know, that was obviously the birthplace of the city. It was the birthplace of settlement. And so it's almost like we're sort of going back to this idea of, you know, adaptability, but genuine adaptability, where it's entirely.
We don't own land. We don't own land. Nobody owns land. And I think Latour is right about the kind of a new territory.
It's cut out again. The sound is gone. I'm just going to let Rachel know the sound is gone. Oh, no, she's coming back. It's okay.
I think I need to get onto the second question.
Yeah, your sound has just it just went out then a little bit. I think your Wi-Fi connection is slightly dodgy, but it's okay. So Rachel, we just have one more question. Oh, it's gone out again. I might have to re-invite Rachel. I'm going to send another invitation. Sorry about this. We've got a few Wi-Fi connections. We've got general technical issues today. Oh, Rachel's coming back. She's moving. She will come back in again because she knows that when it drops out, we have to reconnect again. So I'm just going to send a connection to Rachel and she will. Okay, I can see Rachel's online, so she should be back shortly. We've got a comment here, nomadic ecosystems, maybe even to other planets. Well, yeah, you know, Rachel's actually she's authored a book on that very subject. There she is. Hi, Rachel.
I got closer to the Wi-Fi.
Brilliant, brilliant. Do you know what? It's really weird. I found with these sessions, some days it's flawless technically. Other times it's just all over the place, but it's okay. We are shape-shifting with this situation. So one more question, Rachel. You have one wish. If a genie popped out of a magical lamp or a test tube, a petri dish, or even a microbial reactor and granted you one wish for our biofutures, what would it be and why?
12-volt home for everybody, made of microbial fuel cells.
Brilliant. I love that. Yeah, that's brilliant. That's the shortest but the clearest of the visions we've had today. Well, it's been a real pleasure speaking to you today, Rachel. As ever, there's a massive list of things that we haven't been able to cover, but I'm sure we will get round to those things again. For those that don't know Rachel's work, she has so many good books, so many good works, articles, talks. I will share some of those. So maybe, Rachel, if you send me some of the things you think people that really want to know more about your work should know, then I will share that with the community because it's
okay. Thank you so much, Melissa, for this invitation. It's, as always, just an absolute delight to talk to you. And hey guys, thank you so much for hanging out for all this time. I'm so thrilled that you have. Really, it's so great to see people here. So first time on Instagram.
Yeah.
Maybe it's not the last. Yeah. I'll get a little bit more tech savvy, but no, really, thank you so much, everybody. This has been a great afternoon, and I hope to see you all again. Thanks, Melissa.
Brilliant. Well, thank you, Rachel, and thank you for everyone for bearing with us through the tech issues. But I hope that sparks your imagination. Next week we're carrying on the microbial community question next week, because we have Richard Beckett from the Bartlett will be coming with us to talk about his latest project, we will hopefully have we will have Dr. Carolina Ramirez from RCA, who you came up in conversation because you're actually her examiner in her PhD. She will be dropping in because she worked with Richard on that Droplet project. So yeah, we're going to be carry on talking about microbes next week, and I will let you know who is coming the week after that very shortly. So take care, Rachel. We will catch up soon. Bye for now, everybody.
See you all again, everybody. Bye-bye.